Algebra 2, Mr. Stirrup here. I be at the lab this morning, so hey, make sure you watch this whole video. I'm going to try and clear up everything I goofed up probably yesterday, so hopefully that works for us. First off, feasible region. It's the yellow region. It's the bound region. It's the shape. Okay, this one's bounded by the x and the y-axis as well. And all you need to do on these problems is you look at the corners. Okay, and this is kind of what I did yesterday. So I have the corner 0, 5. I have the corner 4, 2. It's the intersection. I have the corner 3, 0. And I have the corner 0, 0. Okay? So I'm looking at the corners. When I plug those corners into this equation, this is a cost equation because it starts with a C. If it was a profit equation, it would start with a P. And all I'm doing is I'm just going to plug this in. So if we use this one first, I have 3 times 0 plus 2 times 5. So that's going to give me 10. So that would mean it cost me $10 if I chose 0 of one and 5 of another item or product. Okay, we're trying to think about selling stuff. Then if I plug 4, 2, and I get 3 times 4 and 2 times 2, 3 times 4 is 12. 12 plus 4 is 16. Okay, so that's going to give us a cost of $16. If I plug 3, 0 in, I get 9 plus 0, so that's going to give me 9. And then if I plug 0, 0 into this, I'm going to get just 0. So you look and you say, okay, what's my largest number? Well, the largest number is 16, so that's going to be called a maximum. The smallest number is 0, so that's going to be called a minimum. The other two just work out. So knowing that, we're plugging corners in to an equation. This equation here is not graphed on our graph. Okay, this equation is just saying, hey, plug the corners into me and let's figure this out. Okay? So moving on. So now, notice this is in quadrant 1. We're just in a positive region. So let's go ahead and graph this. So this means, hey, we're dealing with everything to the right of the y-axis. Okay? So that's what that looks like. And then if I look at y equals 0, that means I'm dealing with everything above the x-axis. And then the other two, I could use my calculator, be sure to do slope-intercept form, or you could realize I could do this using the cover method. Oops, let's undo that. We could use the cover method to solve this. So that would give me an x value of negative 15. Well, negative 15 is not even on there. And then a y value of 5. Well, maybe we should break this up to give me 3 is less than or equal to x, added to x both sides, plus 15. And then y is less than or equal to 1/3 x plus 5. Okay, so I'm just solving this equation to give me that. So I have positive 5 as my y-intercept. I have a slope that goes up 1, right 3. And let's make that a purple line. So can you start seeing there's some shape to it? I have my x and y axis, and then I have I graphed the last one, and then I'm going to graph this last equation. It looks like the cover method might work on this one because I have the right values. So if I cover up, if I go 2x equals 12, so x equals 6, which is down here. And then y is 12, so that's up there. And again, we'll try and make it nice and neat with a nice line. Okay, so we have some regions up here which look great, and I want values that are greater than 0, so we're talking here. I want greater than 0, so we're talking here. I want values that are underneath here, so if I pick 1, 1 and plug it into this, so that could be a test point. So hopefully that's the shaded region down here. If I pick 1, 1, 0, 0 is not going to work because we're not dealing with that part of the region. If I plug 1, 1 and I get negative 1 plus 3 is less than 15. That's true. If I plug 1, 1 into this, I get 2 times 1 is 2 plus 1. That's 3. 3 is less than 12. That's true. So this region down here is my feasible region. Can you see the shape that it made? So now I want to find the corners of this shape. And they tell us we have this cost equation. So we want to find the maximum and minimum value. So it looks like This is the point 0, comma 5. This is the point, it appears to be 3, comma 6. Those are my corners. This is the point 6, comma 0. And then the real easy one, a lot of people forget, is 0, 0. So I'm going to take all of those and I'm going to plug it into this equation to see which one gives me the max, which one gives me the min. So 2 times 0 plus 4 times 5, this one's going to give me 20. But I plug 3 and 6 in, I get 2 times 3 and 4 times 6, so I get 6 plus 24, so this is going to give me 30. So right now that might be our biggest value. If I plug 6, comma 0 in, I'm going to get 12 plus 0, so that's just 12. And then if I plug 0, 0 in, toughest one, it's going to give me 0. So if we want to find the maximum and the minimum, this is my maximum value because it's the largest number, and this is my minimum value because it's the smallest value. Okay, so again, you're just drawing lines and seeing where it graphs, and it's an inequality. That's all these are. Okay, so we're going to look at this. So we know by doing that and that means that we're talking about it's in quadrant 1. Okay, so we're going to be bound by the x and the y axis because of that. The second problem here, I can go ahead and graph that. It's already slope-intercept form, so I have 6 right here. And I'm going to go up 1 right 2. And I'll use my straight tool to draw it. So it looks something like that. And I'm not worried about crossing over the x and y axis because our bound region we're not worried about. Again, this is a cost function because we're using this. This is not graphed on this graph at all. And we'll do this one in blue. Looks like the cover method will work on this one. So I'm going to get an x value of 5. I'm going to get a y value of 10. And we're going to go ahead and do this. And again, we already knew from our first 2 constraints that we had up top that this is dealing with this region. Okay? And I could pick a test point, but for right now, we're dealing with a bounded region. That's really only the bounded region. Yes, I understand we have this, but we want to have everything there. So if we take a look at how this is graphed, where are the intersections? This right here appears to be 0, 6. This one, my line is a smidge off, but I would say it's got to be 2, 7 if you looked at the intersection of it. This, it looks like it's going to be 5, 0, and this one down here is 0, 0. So again, I'm going to take each of those and I'm going to plug it into our cost equation. And again, I'm using this region because of these as well. So my cost equation, I'm going to plug it in. So let's take this one. So 0 minus 6, so this gives me an answer of negative 6. Oh, that's kind of small. And this is going to give me 2 minus 7, which is negative 5 in our cost equation. And then this one's going to give me just an answer of 5. And 0, 0 is going to give me an answer of 0. Well, here's my max because it's 5. What's my min? Negative 6. Why is it not 0? Because negative 6 is smaller than 0. Same thing. We're using quadrant 1. We're looking at these and this. I'm going to use this first equation. We're going to use the cover method. So I'm going to see that it crosses here at 5 and also here at 5. Okay, using the cover method. And then I'm going to just do a black line. Okay, and then my second equation, it looks like I could do that maybe in green. Cover method will work on that one as well. Another cost formula. It's not part of the graph. So that's going to give me 6. And then 4 goes into 18 4.5 times. So this is actually crossing here at 4.5. And this one's going to be a little tougher to take a look at. And we might have to use the calculator to see it. Oops, undo. Didn't do what I wanted. So it looks like these 2 equations cross right there. So I know that this is the point 0, 4.5 or 4.5. I know this one is 0, 0. and I know that this one is 5, 0. And on my graph, it doesn't look as clear as I wanted it to be. So I might have to convert both of my equations into slope-intercept form. So I'm going to graph this, y equals negative x plus 5. And I'll do that on the board in a sec. And then this one, that's going to give me 4y equals negative 3x plus 18. And then y equals negative 3/4 x plus 9 over 2. All right, so let me just write those two equations down on this board so I can refer to it. And I'm going to use the graphing calculator to make that happen. So we'll switch over here. So let's go into y equals. Make sure we don't have anything there. Well, I'm going to clear all these things out. I don't need these at all. And so my first equation is negative x plus 5. And my second equation is going to be negative 3/4 x. Remember, put it in parentheses. Oops, I already goofed it up. And that was 3/4 x plus 9 over 2. Okay, and if I do zoom standard, which is zoom 6, that's going to take me negative positive 10. And it does appear that they do indeed cross each other. So now we're going to go second, calculate an intersection, which is number 5. The first curve, it's on the blue, hit enter. The second curve is on the red, hit enter. Do we want to guess? No. We want to keep it going. So the intersection on this one appears to be 2, 3. Okay, so 2, 3, we're going to come back to that. And remember, we said that's going to be 2, 3, right? All right, so if we plug our values in to our cost equation, so 0 plus 4.5, well, what's 6 times 4.5? I don't even know. 30, carry 3, 24, 27.0. So this gives me an answer of 27. 2, 3, if I plug those in, right, I'm going into this one, I'm going to get 10 plus 18, which is 28. 5, 0, that's going to give me just 25 for an answer here, and then 0, 0 is going to give me 0. So our maximum is 28. Our minimum is going to be 0. That's all that goes with that. Okay, we're not making up the equations yet. We're just dealing with them. All right, now let's take a look at this one. Here's our cost equation. It's not going to be graphed at all. We're just going to use that for the corners. All right, so now we have to think. What does an x equals 0 look like? Well, it's a vertical line right here. Okay, so here's a vertical line coming straight down. So it's the origin. And then at 50, what is that going to look like? Well, that red line's my thing. So let's say, looks like if we count by, oh, I don't know, maybe go 10, 1, 2, 3, 20, 1, 2, 3, 4, 30, 1, 2, 3, 4, 40. Okay, and then that's all the way out to 50. All right, so what does x equals 50 look like? Well, that's another vertical line that goes through 50, so it's all the way over here. So now we're going in between these two. Okay? And then look at the y direction. That's saying, okay, we're going to do 40. All right, so let's do the same thing. So here's my x-axis. And then 40. Let's do the same thing. We're going to count by every 4 spaces. So 1, 2, 3, 4, that's 10. 1, 2, 3, 4, that's 20. 1, 2, 3, 4, that's 30. 1, 2, 3, 4, that's 40. And we get 50 at the very top if we might need that. Okay, who knows? But we're going to bound up to 40, so that's a horizontal line. So we'll do that one in green as well. Okay, got 40, so that's right here. So notice I have a square or a rectangle up there. But then I have one last line that we're going to deal with, and that is my last equation. Let's see if we can figure this one out. So cover method should work. X is going to be giving me 0, comma blank and blank, comma 0. So that's going to give me 80 in the x direction. Oh shoot, that's going to be way out there, isn't it? And then in the y direction, it's going to give me 60. So 60 is going to happen up above here. And so now you're like, okay, that's happened off our screen. Well, that's okay. We only need to find the one intersection of that line between these 2 points. Okay, so we're going to get there. All right, so I know I have 0, 0 down here. I have 0, comma 40 right there. I'm going to find out that one, and I'm going to find out that one in a moment. And then this one down here is 50, comma 0. All right, so how do you think we could figure this out? Well, this right here was a y value, correct? So my y value is going to be 40. Well, if I take that y value and plug it in there, that becomes 3x plus 160 equals 240. So 160 subtract that is going to give me, can't do it in my head, I apologize, long day. 160, 0, 80 divided by 3, so 80 over 3, ooh, yuck. Okay, that'll actually work out pretty nice in our equation, but we'll get there in a moment. And then this one, we have to remember that this was a x value of 50. So if I take my x value of 50 and plug it in there, I'm going to get 150 plus 4y equals 240. If I subtract that, I'm going to get 4y is equal to 90. So y is going to be 90 over 4. 90 over 4 reduces to 45 over 2. So then let's go ahead and use our constraints. Okay, so 0, 0 plugged into this gives me 0. I think you're all probably comfortable with that. 0, comma 40 gives me negative 160 here. This one, if I plug in 80 over 3, this one right here is going to become just 80. Minus 160 is negative 80. And then if I plug this one in, I'm going to go 150 minus 90. 150 minus 90 is 60. And then if I plug 50 in, that becomes 150. And so then we have to start looking, saying, well, 150 is my max. And my minimum is negative 160. Okay, this is still bound by the constraints. I think you can still do it. This is going to be still, you have a vertical line here and here. You're going to have a horizontal line here and here. And then you're going to be like, okay, if I use the cover method on this, again, this is the same exact problem we were just doing. So this is going to give me x is 60, which is there. Y is, actually take that back, x should be 80, so we're out here, and then 60, and then we're doing this. So again, it's the same problem we just did, it's just with the graph a little nicer. Okay, So graph the constraints. You're making a shape, and you're shading inside the shape. Find the corners of the shape. Include 0, 0 if it's going to be there. And then you're going to put all the vertices into either the cost or the profit equation. Identify the largest value as the maximum, the smallest value as the minimum. Okay? So with that, then we're going to go to, this is still in your notes for today. All right, so we're going to develop understanding how to write constraints, optimize. So now we're going to start writing the equations to it. Okay, so it says here, small manufacturer of skateboards and scooters can devote up to 20 hours per week in manufacturing, 2 hours per scooter, 5 hours per skateboard, up to 7 hours a week has been allocated to detailing, 1 hour per scooter or skateboard. A minimum of 8 hours is spent on customer service, 2 hours per scooter, 1 hour on skateboard. So use a highlighter to find the values needed. Write 5 inequalities. Okay? Well, before you start panicking with the inequalities, let's just look forward and see what we have. We have here, here. Well, where did this one come from? X plus y equals 7. Let's go back and take a look. Okay, what gave us 7 up here? Actually, that's not going to... Okay, so let me highlight a few things. Oh, wrong key. Okay, so scooters can devote up to 20 hours for manufacturing, 2 hours per scooter, and 5 per skateboard. And then we have up to 7 hours a week. That's my 7 has been allocated for detailing, 1 hour per scooter, 1 hour per skateboard. Okay, and that's going to be one of the equations we looked at. And then a minimum of 8 hours per week is spent on customer service, 2 hours per scooter, and 1 per skateboard. So the purple, let's take a look at that on the next screen. Would that make sense? X plus y is less than or equal to 7. Well, it said we spend 7 hours on our detailing of our scooter. Okay, so we took care of our first one. Okay, so let's see where the 22 and 5 falls in. Well, that looks like here. I have 2 hours per scooter, 5 hours per skateboard, and I have 20 hours that it's equal to. And then that's going to be my pink. And then my blue color, I have 8 hours per week is spent on customer service, 2 hours per scooter, 1 hour per skateboard. So there's my last equation is there. Okay, so we don't have we just have graphing that we want to do with that. And let's see what happens. Well, this first one, that means here, this one, let's make that red, means I'm going here. Make this one green. Cover method, so 7, 1, 2, 3, 4, 5, 6, 7, and 7, 1, 2, 3, 4, 5, 6, 7. Let's try the best I can. And maybe we can do this one in purple. Cover method's going to work nicely here, so 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7, 8. Oh, they intersect each other, so that's going to mean something. We're a problem. And then my last equation, I'll make it orange. Cover method's going to work, so I got, looks like 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's all the way over here. And then 4, 1, 2, 3, 4. So we have a feasible region that we have to make sure is going to work. So I'm going to quickly just use 1, 1 as my test point. It works here. It works here. Is 1 less than, or is 1 plus 1 2 less than 7? That's true, so it's under the blue. That works. Let's go to the purple. Let's plug 1 in, 1 in, 1 in. So 2 times 1 plus 1, that's 3. Is 3 greater than 8? And that's going to be false. So I'm going to shade on the other side of the purple. And then on the orange, let's see if we shade still underneath it. So I'm going to plug 1, 1 in still. And so I get 2 times 1, 5 times 1. So that's going to be true. So our bounded region that we're worried about graphing is here. Okay, so we're not worried about 0, 0 in this one. So I'm going to get 1, 2, 3, 4. So that's 4, comma 0. I got 5, 6, 7. That's 7, comma 0. The reason we're not going outside of it is we need to be underneath there. And then I have one last corner to get to, and that looks like actually 2, 1, 2, 3, 4, 2, comma 4 if I graphed it right. And you might see it a little different on yours if you didn't use a straight edge. I didn't use a straight edge. I freehanded it and got lucky. But this is our bounded region, and these are our constraints that we'd be plugging into our equation. So 2, 4, 4, 0, and 7, 0. Okay? So a profit function is 8x plus 11. A cost function is that. So they look very similar. Which one do you want to minimize? A minimize, you want a cost. You want your minimum value of cost when you're running a business. You want to maximize your profit because you want to make money, right? All right, so let's look at this. A bakery is making whole wheat bread and blueberry muffins. For each batch of bread, they make $35 profit. Okay. For each batch of muffins, they make $10 profit. For the bread takes 4 hours to prepare and 1 hour to bake. The muffins take 0.5 hour to prepare and 0.5 hour to bake. The maximum preparation time available is 16 hours. The maximum baking time is 10 hours. How many batches of bread and muffins should be made to maximize profits? Okay, so you're running a bakery. I know you might not do that for the rest of your life, but you're just running a bakery. So let's take a look at what our graph is going to start looking like. We have this up. And do we have any equations that are given to us? I haven't looked further on the slides. Okay, cool. All right, so now we need to start making our information. So I'm going to kind of highlight a few things. Okay, highlighter. Okay, we're making whole wheat bread and blueberry muffins. That's not really an equation. For each batch of bread, they make $35 profit. Okay, so this is a profit equation. Okay, so if you wanted to write your equation out, you're going to have the whole wheat bread, we'll use W, and then the blueberry muffins, we'll use B. Between what we make between those is 35 bucks for profit. Okay, for each batch of muffins, so I'm going to start highlighting this next one. For each batch of muffins, they make $10 in profit. So muffins, which was B, they make $10. The bread takes 4 hours to make, so the whole wheat. The bread takes 4 hours to prepare and 1 hour to bake. So if I was to take my whole wheat bread, which is the W, I have 4 hours plus 1 hour, so you're looking at 5 hours it takes to deal with that. And then the muffins, the blueberry muffins, the B, takes 0.5 and 0.5, so that's only 1 hour. Okay? And you have a maximum preparation time of 16 hours. So between the two, the maximum baking time is 10 hours. So between these, you have the exact same equation. So you have a prep time that, you have maximum preparation is 16 hours, maximum baking time is 10 hours. So how many batches of bread should you make? So the equation, these are your equations that we're going to go ahead and graph. Okay, do we need to convert them to X and Y? Probably. Okay, but if you move forward onto your homework, you're going to start seeing these make a little bit more of a difference. All right, so let's see if we can, if we graph that. All right, so what I want to give you is the worksheet 3B, I want it done. The worksheet 3C, I want you to try it. And when I say try it, don't come in with a blank on Monday. So I'm going to be checking this one off on Monday, but I want this one tried because we're going to have to spend a lot of time just going through it and washing through it. Okay? But those are the what I want done for Monday. And that's all I got for you. So I only did 30 minutes. So try and start working on those, getting them complete. Hope you guys have a great weekend. Oh, I guess I owe you a story. What story do you want? How about the time I had a student who came walking into class and she knew that I like to do food dares. And this is, gosh, 15 years ago. Well, she came walking in, she had her goldfish in, not the crackers, but an actual living goldfish in a bowl. And she says, I bet you don't have the guts to eat my goldfish. Well, I got the goldfish out of their little bowl. I put it in my mouth and I swallowed it. And as soon as I saw the look on her face, she was horrified that I ate her goldfish. Unfortunately, the goldfish made it down into hydrochloricville stomach, and I'm sure didn't survive. But yeah, that might have been about the dumbest thing I've done as a teacher, eating a student's goldfish who dared me to. So please don't dare me to do stuff, because unfortunately sometimes I do. And now you guys all have cameras, and you'll have credit, and I'll have the people for ethical treatment of animals coming after me. So yeah, that was goofy stuff. But that's my little silly story. Hope you have a great weekend. Take care of one another, and be awesome to the sub. Make sure if you did borrow a Chromebook that you put it back and plug it in to be charged. Thanks, guys. Bye.